Good afternoon, everybody. My name is Chris Day. I'm VP of Marketing at Ambarella. It's great to join you all today here at Interdrone 2015. I think it's the first time we've ever been at this show, and it's really exciting, really fantastic. Let me begin with a quick introduction to my company. We are a semiconductor supplier that focuses on high definition and ultra high definition chips, primarily for cameras. We initially provided chips for broadcast television. If you watch DirecTV or Dish Networks or AT&T, you are probably watching video that has been encoded by Ambarella compression chips. We provide chips for about 1/3 of the world's IP security cameras. Has anyone here recently been caught speeding by a traffic camera? Yep, you have us to thank for that. We also provide chips for most of the world's wearable sports cameras, with GoPro being the leader and the most famous. And recently, we have been providing chips for drones, most notably for DJI. Here's a picture of the incredible DJI Inspire 1, which includes 4K or Ultra HD video. I'd like to take this opportunity to discuss the evolution of video in drones, or as we call them, flying cameras, and to look at what we might expect to see in the future. Let's first look at some of the amazing ways in which flying cameras are shaping the world of videography. Makes me want to visit New York again, but not in winter. At Ambarella, we are seeing very rapid growth in this market. The killer app for drones is aerial photography and videography. No longer satisfied with just flying drones for fun, customers want to record images and share these images with friends, or in the commercial world, customers. And the range of available drones is growing very rapidly. Let's check out a few of the most recent flying camera introductions. Firstly, the new unique Q500 Typhoon 4K, which includes 4K Ultra HD video and 12 megapixel stills. Oops. Secondly, the 3D robotic Solo with computer-assisted flight and advanced camera control of the GoPro Hero 4 camera. And thirdly, DJI's Phantom 3 family, which includes Ultra HD models, as well as the new Phantom 3 Standard, which begins at only $799. So many different models, but one common denominator: high-quality video. It is video that is driving demand in both consumer and commercial markets. And video is not just about recording. The ability to stream live video also enables new piloting capabilities, as you can see the view from the drone camera on your handset or goggles. And of course, live video streaming also enables new and engagingly fun activities like drone racing. Really looking forward to doing that, although I think I'm going to be quite dangerous, to be honest. So with the camera becoming increasingly important, I'd like to discuss the evolution of video recording and then describe some of the things we intend to enable in the near future. Let's go back in time. Well, this may be a little bit too far back, but who says aerial photography is new? And you know, in 1882, British meteorologist E.D. Archibald pioneered kite aerial photography, and the first use of motion picture cameras being mounted on an actual aircraft took place in April 1909, and the Wright brothers had a hand in that. Hopefully you see some 21st century parallels. Now to more recent times than this century. So Ambarella has been driving the evolution of HD video for about 10 years. We initially provided the chips for solid-state camcorders and handheld cameras, enabling consumers with high-quality, full HD video and at radically new price points. 10 years on, and these actually look quite ancient, but prior to these products, people were still using tapes and suffering poor quality, low-resolution video. Now moving forward to 2009. In 2009, we had the very good fortune to meet a young Nick Woodman, CEO of GoPro, at a CES show. Nick had the idea of building a wearable sports camera. His original idea was to develop wrist straps that could tether a camera to surfers' wrists. And he tested out these wrist straps on surfers in Australia and Indonesia. And pretty soon he came to the conclusion that he actually needed to supply the complete camera and that that camera had better be waterproof. Well, Nick didn't have any engineers at the time, but he had a great idea, and we worked with him to develop the first Hero HD wearable camera. Originally for surfers, GoPro has now become a must-have item for snowboarders, skateboarders, skiers, and other sporting arenas. GoPro has fundamentally changed the video paradigm, from just holding a camera to shoot away from the user, to allowing the user to film him or herself immersed in sport in action. Let's check this out. Yeah, that would be me. And a little under 3 years ago, we met with a Chinese startup, DJI, a pioneer and leader in the drone market. DJI is an incredibly innovative company. We started working with DJI on their Phantom 2 family, which included a gimbal-stabilized full HD camera with 14 megapixel stills. Integration of the camera with the drone allows the Phantom 2 to stream video to smartphones or tablets for piloting and for flight monitoring. More recently, DJI has driven the transition from high definition to ultra high definition with the introduction of the Inspire 1 and the Phantom 3 Professional. The latest mobile applications let users control camera settings, including ISO, white balance, and exposure, to optimize photography and video recordings. Now let's look at some of the challenges facing flying camera designers and see how the latest technology can address them. We'll focus on the following: 4K video compression, image stabilization, high contrast scenes, video frame rate, and wide-angle video dewarping. So firstly, Ultra HD or 4K video. It's 4 times the resolution of Full HD, and because it looks fantastic. With drones having to capture video over large distances, the advantages of 4K are immediately obvious. But 4K produces a lot of data, and that data has to be handled, so uploading the files can take a long time. Additionally, there are constraints on the wireless bandwidth available to transmit the video back to the user. So typically, the live video feed has to be at a lower resolution than the recording. Today, Ambarella is a leader in video compression efficiency using the current H.264 video standard, resulting in the highest video quality and lowest bit rates. But there is now a new video compression standard called HEVC, High Efficiency Video Coding, or H.265, which offers a 50% bitrate saving over H.264. Why is this important? Well, HEVC cuts upload time and provides higher quality video at lower bit rates. Importantly, when combined with low delay encoding, it allows high quality wireless video streaming. The next big issue facing flying camera designers is image stabilization. The flying camera application is inherently shaky and must be stabilized to achieve pristine video capture. Some low frequency vibrations are due to wind and changes in flight directions or speed, while higher frequency vibrations are often due to the rotor operation in the drone. In addition to shaky video, you may also have experienced something called jello effect, wherein the video looks like it is stretching and wobbling. This is actually something called roll-in shutter effect, and it's caused by camera motion during the image capture between the beginning and end of the frame. Today's high-end drones typically use mechanical gimbals to stabilize the video. However, digital electronic image stabilization, or EIS, has the advantage of reducing the physical design complexity while also saving cost. Ambarella's advanced EIS algorithm with roll-in shutter correction can be used to correct aberrations caused by both low and high frequency vibrations. Additionally, we can correct not just for X and Y, or pitch and yaw, but X, Y, and Z rotation. That's pitch, yaw, and roll. So we anticipate that advanced EIS will be used to improve image stabilization, not just in lower-end drones without gimbals, but also in conjunction with mechanical gimbals to improve image stabilization in higher-end models. Another challenge, how to handle high-contrast scenes. Drones often shoot video in very challenging lighting conditions, such as here in this scene. You get either under or overexposed video. And the way to correct this is to use something called HDR, or high dynamic range processing. HDR involves taking multiple images at different exposures and then combining them together to enable more detail than would have been possible with a single exposure. Now, HDR has been common for still photography, but it is much more difficult to implement for video, wherein multiple frames have to be processed every single second. Also, during fast motion scenes, motion blurring can occur due to the time differences between the time that each frame is captured. Looking forward, improvements in video HDR processing combined with new line interleave sensors will enable HDR at higher frame rates and would significantly reduce motion blurring. So HDR is no longer just for still pictures. Another area in which we will continue to drive performance is video frame rate. When recording video of fast-moving scenes, such as adrenaline sports or car racing, or with a flying camera moving at high speed, it's important to use a higher frame rate to avoid choppy-looking video. Additionally, the use of higher frame rates can enable smooth, slow-motion playback, which can be fun. So check out this GoPro video that demonstrates what can be done when we push frame rates up to 120 frames per second. Now, next-generation chips will push 4K video to new and higher frame rates, so that users no longer have to trade off resolution when shooting fast-action scenes or slow-motion videos. For example, Ambarella's H1 chip, introduced at CES this year, captures 4K video at up to 60 frames per second and Full HD at 240 frames per second. One last challenge, how to shoot wide-angle video without getting distortion. See the image behind me? This is typical of a video shot with a wide-angle lens, and it has a lot of distortion. Check out the horizon here. The wider the field of view, the wider lens you need, and the more distortion you will get. And it takes a lot of performance to correct this distortion in real time, at resolutions up to 4K and at high frame rates. That is why the latest video chips add hardware de-warp engines to correct this distortion in real time without having to sacrifice frame rate or resolution. The result is beautiful 4K Ultra HD wide-angle shots with virtually no distortion. So far we have looked at the video technologies that are going to make the next generation flying cameras even better. Now let's think about what the flying cameras of the future will look like and what they'll be able to do with video and in particular computer vision. So some drones have been able to sense their environment for some time now through a mix of cameras and other sensors. However, flying cameras in general are still in their infancy when it comes to computer vision. Put your flying camera in follow me mode and go skiing through ravines and trees, and you may never see it again. This is actual flyer from my neighborhood. I was actually going to title this slide Lost Parrot, but I thought it might be rude to the parrot guy, so I didn't. So. With advances in computer vision technology, flying cameras will become advanced enough to be able to navigate by themselves, based mainly on video data, and to use this data to avoid obstacles, to follow people, and to keep track of their position. Ultimately, they can become fully autonomous. This clip shows computer vision being used to create a real-time model of the environment for autonomous navigation. This has been developed by our Italian computer vision team, initially for use in cars. But similar technology can be applied to flying cameras in future. It's actually quite funny. If you look at the guy's face walking across the zebra crossing, he looks at the car and then he looks again because he realizes there's nobody behind the wheel. It's quite entertaining. As flying cameras become more autonomous, a new era for commercial applications will open up, with flying cameras no longer having to rely on local operators. Consumers will also be able to enjoy the benefits of aerial videography, freed from the difficulties and risks of piloting. To meet the extreme processing performance required for the latest computer vision algorithms, a new computer vision processor architecture will be required. It must be optimized specifically for computer vision algorithms and operate with very, very low power. And of course, it must also deliver stabilized, high-quality 4K video, both for recording and to enable the computer vision algorithms to run efficiently. We at Ambarella look forward to working with you to enable the next generation of flying cameras and the generation beyond that. I'd like to thank you for your time today. I hope I've been able to shed some light on the new video technologies you can expect to see in flying cameras in the future. And thank you also to the following videographers for the content provided today. Thank you.